Section 11.1 is on permutations and combinations. The fundamental counting principle says that if event M can occur in M number of ways and is followed by event N that can occur in N number of ways, then event M followed by event N can occur in M times N ways. Here's an example. So most California license plates are one digit followed by 3 letters followed by 3 more digits. So how many license plates are possible? So for the first place, since it's a digit, we have 10 choices. So there's possible 10 for the first place. Then the second, third, and fourth places are going to be letters, and we have 26 choices for each one of those. And then the last 3 places have to be a digit, and we have 10 choices for each one of those. So plugging that into your calculator, you get 175,760,000 possible license plates. Now that's not actually accurate because I've never seen a license plate that starts with a 0, and to be honest, there are certain letter combinations that they do not allow. Okay, a permutation is an arrangement of items in a particular order. Suppose you have 5 items that you need to put in order. There are 5 choices for the first place, 4 choices for the second place, 3 for the third, 2 for the fourth, and 1 for the last. Using the fundamental counting principle, this would be 5 times 4 times 3 times 2 times 1, which is 120. We can use factorial notation to express this, and that's written as 5 exclamation point, and we read it as 5 factorial. And by definition, 0 factorial is equal to 1. So here's an example. In how many ways can you arrange 7 teddy bears on a shelf, one right after another? And that would be 7 factorial, because you have 7 choices for the first spot, 6 for the second, and so on. So how are we going to do that? I don't really want to do 7 times 6 times 5 and so on. You can actually do this with your graphing calculator. So I'm going to start by putting in the number 7, and then I'm going to go to the math menu, or hit the math button, and then go over to the probability menu. It might be just a PRB in your calculator. And then we're going to go down to the exclamation point, which is number 4. Hit enter, and then hit enter again. So 7 factorial is 5,040. So there are 5,040 different ways that you can arrange 7 teddy bears on a shelf. Sometimes you don't, whoops, sorry about that, hold on. There we go. Sometimes you want to arrange only a certain number of items in a set. So maybe I don't want to arrange all 7 teddy bears. Then we're going to use the permutation formula. The number of permutations of n items of a set arranged r items at a time is written like this. So it's a subscript n, an uppercase P, and a subscript r. And that's defined as n factorial divided by the quantity n minus r factorial, where r is greater than or equal to 0 and n has to be greater than or equal to r. So here's an example. Is that going to work a little better? There we go, that's good. In how many different ways can a first, second, and third baseman be selected from 8 players? So my total number of players that I have is going to be 8, so that's going to be my n. And I'm looking to choose 3 players since I need a first baseman, a third baseman, and first, second, and third baseman. So I would write that as 8p3. And that comes out to be, using the formula, 8 factorial divided by 8 minus 3 factorial, which is equal to 8 factorial over 5 factorial. And now I could write all of this out. I could write this out as 8 times 7 times 6 times 5 and so on. But notice that when I get to 5, 5 times 4 times 3 times 2 times 1 is the same as 5 factorial. And the reason I stopped there is because I have a 5 factorial on the bottom. So I could write out 4, 3, 2, 1 and then 5, 4, 3, 2, 1 on the bottom, but I'm going to cancel them anyway. So if I write it like this, I can cancel out my 5 factorials. And then I grab my calculator, and 8 times 7 times 6 is 336 ways that I can choose a first, second, and third baseman from 8 players. Now, sometimes the particular order of the items selected does not matter. In the previous example, order mattered because I had to have a particular person on first base and a particular person on second and third and so on. If order does not matter, then we're going to use the combination formula. So the number of combinations of n items of a set chosen r items at a time is this formula here. A subscript n, an uppercase C, a subscript r, and that is equal to n factorial divided by r factorial times the quantity n minus r factorial. And again, r is greater than or equal to 0 and n is greater than or equal to r. Notice that the only difference in this formula is it adds this r factorial on the bottom. So let's take a look at an example here. In how many different ways can the principal choose 5 students from a group of 15 to serve on a committee? So my n is going to be 15 because that's how many I have, and I'm going to be choosing 5 students, so that's my r. Now, order doesn't matter. These are just 5 random students that are going to be on this committee. So it's going to be 15 C 5. Okay, now to calculate that, that's going to be 15 factorial over my r, which is 5 factorial, times 15 minus 5 factorial, or 15 factorial divided by 5 factorial times 10 factorial. Now, do not go and multiply that 5 and that 10 and come up with a 50. That's not how it works. So I'm going to take my 15 factorial on top, and I'm going to write it out as 15 times 14 times 13 and so on, and I'm going to stop at whatever is my largest one on the bottom. So this is 15 times 14 times 13 times 12 times 11 times 10 factorial. Okay, because I know I'm going to have that 10 factorial on the bottom, and that's going to cancel out. But I also have to do a 5 times 4 times 3 times 2 times 1 for my 5 factorial. Now my 10 factorials cancel out, and this is going to give me, what did that come out to be? 360,360 divided by 120, which is 3,003 ways that the principal can choose 5 students to serve on a committee, choose 5 students out of 15 to serve on a committee. So sometimes you actually have to figure out whether the situation is going to require a permutation or a combination. So let's take a look at a couple examples here. Okay, so for each situation you need to determine whether you're going to use a permutation or a combination and then answer the question. You have 20 songs on your phone, and how many different ways can you select 4 songs to listen to? Now I'm not saying you have to listen to this song first and this song second, so the order doesn't matter. So this one is going to be a combination. And so I have 20 that I'm choosing from. It's a combination, and I'm going to pick 4. Now let me show you an easier way that you can do this with your calculator. So again, we're going to hit the math button, and we're going to go over to our probability menu here, and you'll see that number 3 here says NCR, so I'm going to select that one. Okay, and my calculator operating system gives me these little boxes. If yours doesn't, you might have to put the value for n in first. But for this I can put in 20, and then I'll arrow over, and it'll let me put in 4, and then I hit enter, and I find out that there are 4,845 ways to do that. 4,845 ways that I can select 4 songs out of the 20 that are on my phone. And let's take a look at our last example here. And how many different ways can the first, second, and third place winners of an art competition be chosen from 15 participants? Because I need to have a first, a second, and a third place, this is going to be a permutation because order matters. Okay. And I'm choosing from 15, and I'm going to pick 3 of them. So again, I'm going to use my calculator for this one, and I'll go to Math, over to Probability, and select NPR because this is a permutation, and I had 15 that I'm choosing from, and I need to select 3. Hit enter, and that's 2,730. So there are 2,730 ways that I can choose a first, second, and third place winner from 15 art competition participants. So in this section we took a look at the permutation and combination formulas and the fundamental counting principle and learned how to use factorial notation.